Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. This is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the IIT JAM Mathematics exam 2024. In this video, we discuss the solutions of two problems from the section Algebra, and both the problems are from group theory, and the questions carry serial numbers 7 and 8. This question is suitable for the aspirants of all these examinations: junior lecturer exam, degree lecturer, TG set, AP set, and particularly this is very important for CSIR, NET and GATE examinations. Right, this is the question number 7. Which of the following is true for the symmetric group S13? We are given 4 options. Option A, S13 has an element of order 42. Option B, S13 has no element of order 35. Option C, S13 has an element of order 27. Option D, S13 has no element of order 60. Right. Let's now discuss the solution of the problem in detail. We recall the following result. The order of a permutation in Sn, the symmetric group on n letters, is the LCM, least common multiple, of the lengths of the cycles in its disjoint cycle representation. So that means you have to take the permutation and write it as the disjoint cycle representation. Then the order of the permutation is given by the LCM of the lengths of the cycles in its disjoint cycle representation. Agreed. Let's go for option A. S13 has an element of order 42. First of all, we factorize 42. 2 into 3 into 7. Right. And when you add 2 plus 3, 5 plus 7, 12 plus 1. 1 also you make it 13. Right. But the LCM of 2, 3, 7, 1 is 42. That means with the help of these factors, we are trying to write down its partition. That is 2 plus 3 plus 7 plus 1 is the partition for 13. But take the factors and the sum of them is less than 13. Right. The LCM is 237. LCM of 237 is 42. Therefore, we have there is a permutation in S13 with 3 disjoint cycles of lengths 2, 3 and 7. Right. For example, you can write down sigma is equal to the transposition 1, 1, 2, that is a cycle of length 2, cycle of length 3, 3, 4, 5, cycle of length 7, 6, 7, 8 up to 12, and 13 is get fixed. Is a disjoint cycle representation. Cycle decomposition. Right. Disjoint cycle decomposition. Right. Now, order of sigma is the LCM of 2, 3, 7. That is 42. Therefore, option A is true. And therefore, the answer to this question is option A. And that is the detailed discussion of the solution of this problem. Yes, I will explain the remaining options also. Let us take option B. S13 has no element of order 35. In a similar fashion, you have to write, and we write 35 as factorization is 5 into 7. 5 plus 7 plus 1 is 13. 5 plus 7 is less than 13, and the LCM of 5 comma 7 is 35. Yes, definitely S13 has a permutation with two disjoint cycles of lengths 5 and 7. And you can write down as an example. Let for example, sigma is equal to cycle of length 5, 1, 2, 3, 4, 5, and cycle of length 7, disjoint 6, 7, 8, 9 up to 12, and 13 is get fixed. And this is the disjoint cycle decomposition of sigma, and the order of sigma is the LCM of 3, 5, 1. Of course, LCM of 3, 5 is 1, is 35. So there is a permutation that has in S13 that has the order of 35. Therefore, the option B is not true. The option B is not true. We move to the next slide. Option C, S13 has an element of order 27. Right. We write a 27 as 3 into 3 into 3. Right. And the remaining are into 1, into 1, into 1 you can put it. Right. Where 3 plus 3 plus 3 is less than 13. But the LCM of 3 is 3, which is not equal to 27. Right. This is not possible. But 27 is equal to 3 into 9. So 3 plus 9 is less than 13. But the LCM of 3 and 9 is, LCM is least common multiple is 9, which is not equal to 27. Right. The last option will be 27 is equal to 27, where 27 greater than 13. But S13 has only 13 symbols, 13 letters. So we cannot have 27 greater than 13. We cannot have a cycle of length 27 with the elements of S13. No, it's not possible. So therefore, we reject this case. So in any case, S13 has no permutation of order 27. Right. Option C is not true. We move to option D. S13 has no element of order 60. Again, we write 60 as 2 square into 3 into 5. That is 2 square is 4. 4 plus 3 plus 5 is less than 13. But the LCM of 4, 3, 5 is 60. Yes. Therefore, S13 has a permutation sigma with 3 disjoint cycles of lengths 4, 3 and 5. And the order of sigma is the LCM of 4, 3, 5. It is not 2, 3, 5. There is a print mistake here. I am sorry for that. So the LCM is not even 237. Is not even 237. It is 435. 435. There is a mistake. I am sorry for that. And now give an example for sigma, as we have done in option A. Give a option B. In option B, we have given an example. So give an example of sigma. That I am leaving it to you as a homework. Right. But in option D, it is given S13 has no element of order 60, but in fact we have an element of order 60. So option D is not true. I am sorry, the order of sigma is LCM of 435. It is not 237. It is not 237. It is 435. It is cut and paste we have done, and there is a mistake that has erupted. So this is what, this is true. This is true. Keep this here. Cut here. So copy here and paste here. Right. So the answer to this question is option A. And that is the detailed discussion of the solution of the problem from group theory related to the order of permutations in S13. Good example. Right. We move to the next question. Right. This is the question number 8. And the question given is, let G be a finite group containing a non-identity element. G be a finite group containing a non-identity element which is conjugate to its inverse. A non-identity element which is conjugate to its inverse. Then which one of the following is true? We are given 4 options. Option A, the order of G is necessarily even. Option B, the order of G is not necessarily even. Option C, G is necessarily cyclic. Option D, G is necessarily abelian but need not be cyclic. Let's now discuss the solution of the problem in detail. We have a finite group G. Right. Given G has an element, say A, which is non-identity, means not equal to E, satisfying A is conjugate to its inverse, A inverse. This is a symbol for conjugate to. A is conjugate to A inverse. Now, that means, what do you mean by A is conjugate to A inverse? A is equal to G inverse, A inverse G for some element G belongs to the group G. Right. Right. We consider two cases. That is, A is equal to A inverse, first case, and A not equal to A inverse. Let's go for the case 1. Suppose that A is equal to A inverse. If A is equal to A inverse, then pre-multiply both sides by 8, then you will get A square is equal to E. From this, you will get the order of A is 2 because A is not equal to E. A is not the order of A, 1, 2 you will write, I know. But A is not equal to E, therefore order of A is not 1, therefore order of A is 2. So order of A is 2. By Lagrange's theorem, order of an element A divides order of G. It is one of the corollaries for the Lagrange's theorem. Right. Order of A means 2. 2 divides order of G. 2 divides order of G. That means order of G is even. So we go to the order of G is even in this case. So we go for case 2. Let us see whether order of G is even in that case. If it is true in both the cases, then order of G is even. So the option A is true, the option B is not true. So we go to case 2, in which we deal with A not equal to A inverse. Right. So case 2, suppose that A not equal to A inverse. Let us take an arbitrary element X from the conjugate class of A. So let X be any element of the conjugate class of A. That means X is conjugate to A. That means X is equal to H inverse A H for some H belongs to G. Agreed. Now X inverse, we take X is H inverse AH. Take the inverse on both sides. X inverse is equal to H inverse AH whole inverse. Right. It's reversal law. Reversal law is H inverse A inverse H inverse, that is H. That is the reversal law. So for H inverse, for A inverse, we write in terms of A. And we have A is G inverse A inverse G. We have A is equal to G inverse A inverse G. Right. We have from the last slide. So you will have H inverse or for A inverse. For A inverse, we write G A G inverse. For A inverse. For A inverse, how do I get A inverse? A inverse, you pre-multiply by G and G inverse. Right. So, because A is conjugate to A inverse in the last slide, what we have written. And from this, A is equal to G inverse A inverse G. We write A for A inverse. A inverse is GA G inverse into H. So that means we will get a G inverse H inverse A into G inverse H. And H is an element of G, G is an element of G, therefore G inverse H is an element of G. So that means X inverse is conjugate to A. X inverse is conjugate to A. That means X inverse belongs to the conjugate class of A. And X is an element of conjugate class of A, will imply X inverse belongs to the conjugate class of A. Now our question is, can X be equal to X inverse? Our claim is X not equal to X inverse. If you assume that X is equal to X inverse, then X is what? X is H inverse AH is equal to H inverse GA G inverse. H inverse GA G inverse. From where you are writing? You are writing from here. You are writing from, don't get panic. You are writing from here. So X is H inverse H is equal to X inverse is H inverse into GA G inverse into H. Now by cancellation, right and left cancellations, you will get A is equal to GA G inverse. That GA G inverse is GA G inverse is A inverse. A inverse. This is a contradiction. This is a contradiction. Is a contradiction because A not equal to A inverse is our case. In this case, A is not equal to A inverse, but we got this one. So this is because you said assume X is equal to X inverse, therefore X not equal to X inverse. So clearly X not equal to X inverse. So what is that we have? X belongs to the conjugate class of A, X inverse belongs to the conjugate class of A, but X not equal to X inverse. So that means if you get into the elements of the conjugate class of A, the elements will be get paired up, an element paired up with its inverse. We can pair up the elements in the conjugate class of A into distinct pairs of the form X, X inverse. So what will be the order of the class of A? From this shows that the order of the conjugate class of A is even. Now we recall in a finite group G, the order of the conjugate class of A is equal to the order of G by the order of normalizer of A. This is all happening in a finite group G. Therefore order of G is the order of the conjugate class of A multiplied by the order of the normalizer of A. And this is even because the order of the conjugate class of A is even. So thus you get order of G is even in this case. In the first case also we have the order of G is even. In any case G is of even order. So this proves option A and this disproves option B. So the option A is true and option B is not true. The answer to this question is option A. Option A only. Right. I will show you options C and D in the next slide. Right. We go for options C and D. These are not true. You have to prove. Go for a counter example. Let G is equal to S3. What is S3? The symmetric group on 3 letters. It is non-abelian. It is not cyclic. Not cyclic and it's non-abelian. Agreed. Agreed. Let us take an element of S3. A is the cycle of length 3, 1, 2, 3, which is not identity. Then what will be the A inverse? You can calculate very easily. It is 1, 3, 2. 1, 3, 2. Let G be the transposition 2, 3. Then 2, 3 inverse, 2, 3 inverse, A inverse 2, 3. That is 2, 3 multiplied by A inverse is 1, 3, 2, 2, 3. Multiply, from right to left you have to multiply, how to multiply the permutations. And the answer is 1, 2, 3, which is A. So that's A. There is an element A, which is not identity, which is conjugate to its inverse. So that's A is conjugate to A inverse, and A is not identity. Therefore, the hypothesis of the question is satisfied. So, G is equal to S3 satisfies the given condition, but G is equal to S3 is neither abelian nor cyclic. Therefore, options C and D are not true. Option C says G is cyclic. So, in this, it's not cyclic. Option D says G is necessarily abelian but not cyclic. It's not abelian and not cyclic also. The option D is not true. So, summarizing all the options, the answer to this question is option A. That is the detailed discussion of the solution of this problem. And both the questions are definitely, this question number 8 is definitely an interesting question. And this question can come in the GATE exam, GATE mathematics exam, or CSIR NET exam. It's very good question. Right. I'm sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Yes, I'm sure I will meet all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.